here. There we go. We are recording. And happy Monday, everybody. Welcome to Interfaces and Polymorphism. Two of I'm sure, our favorite words. Sounds like some people were starting the reading here. Maybe starting the reading, maybe not officially getting through it or getting too scared to continue. And hopefully after this lecture, we'll all have a little bit better understanding about both of these words today. Real quick, I'm going to do a couple announcements. One announcement here is that assignment 2 is right around the corner. It is on Thursday. That being said, catch-up day is on Thursday as well. So just letting everybody know that that is there. If you need any help, if you have any blockers, reach out to your TAs, reach out to fellow students, reach out to me. Get over those blockers as soon as you can. Ask those questions. Don't be afraid to. And just get through that assignment, and we're all here to help you. Second thing is that the studio review, usually I release that at 8:30 tonight. Unfortunately, due to budget cuts, mainly time budget cuts on my part, that's gonna be delayed at least till like Tuesday, Wednesday. I apologize. So I'll put that out there as soon as I can. But you just won't see it tonight. So if you're one of those people that likes to see it right then and there, which I see it like has a little notification on someone who watches it, like the first 15 minutes comes out, whoever you are, you're awesome. But I don't know who it is, but one day I'll track it down. It's like somebody actually has those notifications on or something, or is like following it to the T. But anyway, yeah, so just letting you guys know that will be delayed a little bit. And then finally, for this lecture, try to stay out of the Zoom chat. We did get a couple people just talking that it's kind of like slightly distracting. So just a pleasant reminder to use the lecture chat channel for any kind of chat you want to do there. And also, if you want to ask questions, of course, do the lecture questions. And that being said, I can do something. So I just want to say that, and I think that's it. Is everybody ready to get started? Everybody excited? Everybody gonna make a cup of coffee before this one? I know it is Monday. Any coffee? Any coffee at all? I only have water today, unfortunately.
Two says it's due next Monday.
Yes, the assignment is due next. Yeah, it's right around the corner. It's due next. Yeah, is it Monday or Tuesday? Yeah, no, Monday. The catch-up day and the work on the assignment before it's due is on Thursday.
Gotcha.
Sorry if I miscombobulated anybody. No, you're absolutely correct. All right. Any other questions about the announcements or anything coming up here in class? Okay. Well, in that case, I want to thank the person who called out cake, because today's topic is all about cake. If anyone's seen the Great British Baking Show, I was forced to watch it over the weekend.
I love it.
And I was forced to watch it, and it is gold. But even what's more gold are the gifs and the memes from it. It is hilarious. So I was like, let's make cake this time. It sounds like a Monday thing to do. So we're going to make a cake here. And the first question I want to ask is that if we were to bake up a cake class with the sweetness scale as a class variable, how would I begin to write this? What would I start with always when making a class?
The word class.
Very good. We're going to start with public class and then cake, right? Nothing new there. So what would come next then? We created that cake class. What else do we need from these instructions? What do we need to put in there?
Properties.
Which property in particular? What does it say in our task?
Field.
Say that again.
Sweetness scale.
Sweetness scale. If we knew the sweetness scale was going to be 1 through 10, how are we going to make it? What's going to be its data type? What's going to be its accessor?
Private.
Private, yeah.
Private, and I heard int. So very good. It's going to be a private int sweetness scale. This is our class variable. So let's keep going. What if we wanted to make a constructor to set this class variable? Because right now it's not being set to anything. We need to make a constructor for this. What do we put?
This. It has to have the same name as the class.
So public cake.
Awesome. And then what would be in the parentheses? Remember, from this task, we want, go ahead, please.
Sweetness scale.
It would be, I didn't hear it yet. Kim, I thought you were about to say something. What were you about to say?
Oh, I was going to say you could just leave them open.
We can leave them open, but in this task in particular, it says it wants to set the class variable. So if we want to set the class variable of the constructor, we need to pass something in through the parameters. What should we pass in?
Well, we use a 0 to 10 or whatever.
In particular, we want to pass something into the constructor here. So if a task asks you to set the class variable through the constructor, this is how we would do it. Public, then the name of the class, which is cake. Someone said that, very good. And then we need to pass something in through its parameters. So in this case, we'd say int sweetness scale, because that's what we want to set. We want to set that class variable. And that's what we do in the next line. We say this dot sweetness scale equals sweetness scale. This is how we can translate that task that was asked here into actual code. So any questions about this? If not, one more question. What about a getter? How would we create a getter for this? You need to create a getter for sweetness scale. What would we start with? What's the first word we'd always start with?
Public.
Public, very good. Public and then int, awesome. And then what would be the typical name of our getter method?
Yes.
Get.
Awesome job,
Get
everybody.
sweetness.
And then you'd return this dot sweetness scale. This is how you create a getter. We've all seen this before as well. So this is how we create a typical class. This shouldn't be anything too new to anybody, but just wanted to review some of this. Any questions about what we just did here? All right, let's move on then. We're gonna make it a little bit sweeter here. We're gonna add a taste method because we wanna be able to taste our cake. So I add that taste method down here. We say public void taste, system print out print line, and then it's gonna say what cake is this exactly, because it just says a general cake. If you go into Dairy Queen or your favorite cake store, honestly, I don't know where else, I guess Schnucks or Deerbergs. If you go up to Deerbergs or Schnucks and say, I want a cake, they're gonna ask you, okay, what kind of cake do you want? So this is a very generic class. We wanna make something more specific. So we're gonna create a chocolate cake class. Now, if we wanted this chocolate cake class to use the cake class, someone help me out here. How do we start this?
Public class chocolate cake.
I like that. That's a great start. We're missing one more piece though.
Extends cake.
Awesome. IR high five, virtual high five, extends cake because we want to extend that class. What does that make cake though? What is that called? It is then our
The child.
Parent class.
Inherited.
Class.
Okay.
Ace class.
yeah, either one. Cake is technically the parent class, and then chocolate cake is now the child class. Great. So we just extended cake. Now, if we were in IntelliJ, I'll just be the pretend compiler right now. We would immediately get an error under chocolate cake. It would say, we're missing something. What's the first thing we're missing?
Super.
You have it. What is it?
Yeah.
What's that called?
Constructor.
The
Constructor.
constructor. Very good. We have to add that constructor in there, and we take in that sweetness scale. So what do we put into the constructor if we're a child class? Someone also said that already.
Super.
The super. Awesome. Super job. Super. And what we pass into super are those exact constraints that the constructor wanted, which was that, again, that sweetness scale. So we pass in sweetness scale into super. All right. So now we know that our parent has a cake or has a taste class, but we don't necessarily have to define it in chocolate cake, but I'm going to do it anyway. We want to taste the cake class. And it's going to say, oh, so chocolatey. But I'm missing something here. What am I missing?
Add override.
Awesome job. If we wanted to take in our parent method, taste, and redefine it, customize it, we have to use that at override annotation. That immediately connects it to this one. It says, I want to customize this taste method. That's what that override is doing. So We just created cake. We just created a chocolate cake. Anybody really in the mood for dessert yet? Because I'm totally going to go to Hot Box Cookies after this. Anyway, any questions about this? Anything at all?
I have a quick question.
Yeah, what's up?
All right, so going back to public class cake, when we created the constructor and you passed in the integer sweetness scale, and then it sets sweetness scale to equal sweetness scale, that parameter, or what we would pass through it, is it always the name of the private int variable we created? Or, I mean, wouldn't that, if we were constructing it in some other class, couldn't it be another name?
So yes, this can be any name it wants.
Right.
And
so
that
then,
immediately correlates to this.
correct. Okay, I follow that. So then my question then is, in the next side of it, when we're creating the child, which one of those is it taking? Is it taking in this dot sweetness scale or the private integer sweetness scale, or is it taking in what we pass through it?
Are we talking about at the super? Or are we talking about at the parameter?
I'm talking about both, to be honest with you.
Okay, so this is the parameter. This can be named anything that we want it to be.
Okay.
I can call it new sweetness scale, a sweetness scale, and I still have to pass in that exact same name here.
Okay.
What matters when we pass between constructors is the data type.
Okay.
That's all that matters. It has to be an int that we pass into our super.
Okay, great. Thank you.
Cool. Yeah, absolutely.
But it doesn't have to match the same one from the parent class.
The name?
Right.
No. It can be whatever we want to name it. It's up to our creativity.
So all 4 times that you have sweetness scale there, it could be, those could be completely different things from each other.
Right. These two can be
Okay.
different, and then these two can be different. But remember,
Gotcha.
these two are correlated. So whatever this one is named, it has to be that one. Because it's the parameter, and we're using that parameter. I might have confused you there. Did I confuse you, Haley? Or you got
I get it. It's just, since it was the same word used in both examples, I think we might have thought that it had to be the same both times.
No, and great question. Yeah. Yeah, I try to keep it, the standard is to keep the names consistent. So when you're a developer in a big application, you don't get confused. But it's completely up to you to change those names if you want to.
But then it would be best practices to keep them the same like that and not just make them whatever you want?
Yes, technically it is best practice to keep those names consistent through your classes, just so you know what is what. It's like labeling your cords behind your TV, because those cords are going everywhere. They're going from electronics to electronics. Same with your data flow here. Your sweetness scale is going from class to class. What's the best way to keep your cords straight? Label them. Name them all the same thing. That's what we're doing here. So yes, it is best practice. But again, this is your application, so have fun with it if you want. Get your hands dirty and see what the limitations are. Does that help, Daniel, Haley? Does that help?
Yeah, that did help. Thank you.
Okay. All right, let's see if I can, I think I can click now. Okay, so any other questions on these two cakes? All right, let's dive a little deeper then. We're going to start with cake. What we just did was create a cake class that has taste inside of it. Also, I laughed way too long when I saw this GIF. Like, I don't know why. I just thought it was hilarious. I also cried over cake. It's just sometimes so good, especially cheesecake. Anyway, cake has a taste method inside of it. And it's printed out. What kind of cake is this exactly? Do we all remember this from the past example? Awesome. Then we created chocolate cake. It printed out. We also had that taste method, but we overrode that taste method. And we said, oh, so chocolatey. Again, I love cheesecake. Honestly, if you want to get a passing grade, JK, can't actually do that, but cheesecake is a way to my heart. Love cheesecake. Cheesecake also has a taste method. It says, sweet, cheesy goodness. Cake has 2 children, both have taste in them. Oh, so chocolatey, sweet, cheesy goodness. Both of the children are customizing these taste classes. We just saw that in the previous example. The ability to customize these classes and change them into something different from the parent when we wanted to do different kind of tasting or whatever. This is what that crazy word polymorphism is that we're just morphing the parent methods into doing something different. We're using the same taste method to do something different in the children. This is polymorphism. It's using the same method to do different things. That's it. That's all that crazy word is trying to frighten you about. And to blow your mind already, if this is actually gonna blow your mind, you've already done this. It's nothing crazy. It's just a bigger word now to describe those actions that you've already been doing. So any questions about this?
Yeah, I'm kind of confused about this. I thought you could only extend one class, so I'm probably looking at it wrong. I thought that you could not do what you just did, chocolate cake and cheesecake or extensions of cake.
Right, so cheesecake and chocolate cake, extended cake. Oh, jeez. Let me try to do this. So when it says you can only extend one class, this is what it's talking about. You can only extend cake. You can't extend cake and dessert and pie. You can only extend cake.
Okay.
You can only extend one class. However, cheesecake, carrot cake, other cakes, vanilla cake, they can all extend cake. So multiple children class can have one parent. It's honestly just like a family tree.
Oh, okay.
It's literally just like a family tree. You can only have one mother. No matter how crazy life might get, you can only have one birth mother. Just like classes, you can only extend from one mother. But a mother can have 10 children.
Okay. When you put it that way, I understand it. Okay.
Okay. No, absolutely. All right, back to my favorite gift of all time. All right, so this is polymorphism. And Jaylyn, how are you feeling about this word with 5 syllables right now?
It's looking better. It's looking better.
I'll take better. Okay. Awesome. All right. Well, if we're all done making this cake here, oh, I got one more thing. Again, just remember it's using the same method, just doing different things. All right, let's move on to true or not. Abstract methods must be overwritten by children classes. True or not?
True.
True.
True. You can create instances of abstract classes. True or not?
False.
Nah.
False.
I'm hearing a lot of nah. It is definitely not. We cannot create instances of abstract classes. That is the one big, not downside, but one of the big things about abstract classes. We cannot create instances from them. When overriding a parent class method, you are utilizing polymorphism.
True.
Anybody else? There you go. I see Daniel shaking his head. All right. Yep, that is a true. All right. In ancient America, it was believed that keeping a fruitcake under your pillow would get you a handsome husband. True or not?
All of us would have fruitcakes if that was true.
Well, according to ancient America, it is true. I was looking up cake facts, right? I know. I was looking up cake facts. So if you want a handsome partner, throw a fruitcake under that pillow, because apparently that's what it means.
Oh, and you tell us it's after Christmas. Come on.
I'm sorry. I'm
After we
sorry.
throw
I
them in
found
the
that.
trash.
I know, right? Don't throw them in your trash. Under the pillow now. All right, everybody. Let's go ahead and see this in practice now. So I'm going to go ahead and take this for a sec. Sorry, I forgot to do this before class. All right, so we created a cake class here. So we created our cake class here. So we have our int sweetness scale, we have our constructor, and I'm gonna put enters here. I don't like how they modify that sometimes. And we have our getter for our sweetness scale, and we also made a setter. for that sweetness scale. And then we're tasting it. Any questions about this class? We've seen this before, but this is actually an IntelliJ. It's out in the wild. So anything that looks weird or anything like that. All right, let's move on to chocolate cake. So this one up here extends cake because again, it implements, or it wants to utilize everything that's inside of cake, its parent. When I do that, and just to show you, getting down there in the mud, we come up here and it says, okay, there's a problem, no default constructor available. What this means is that we're missing that constructor. So we go and say, okay, I created the constructor. Everything should be A-okay. And then we get no more errors. But I know that I want my chocolate cake, when someone tastes it, the reaction to be, oh, so chocolatey. So someone help me here. I want to customize that taste class, or that taste method inside my cake class. How would I begin here?
Override.
Very good. And then what's next?
Public
Void.
Keep going.
void taste.
And then we S out. And then so chocolatey. I couldn't spell chocolatey earlier. So I can do it now. I did it. Sweet. All right. So we're tasting that. And then I also made a cheesecake class here too. Down here, we need to do the same thing. We say override. We also make it a little bit easier for us sometimes. Let's see if it does it for me right there. We can just say implement methods. And it's like, okay, what do I want to do? I want to do taste. Yes, please. If we see this, if anyone ever sees this and like, okay, what's actually happening here? Can someone remind me what super actually meant? What is super?
Supersede.
Supersede, it calls up to our superclass, which our superclass is our parent class. Super is basically calling your mom. It wants to call your parent. Super is calling to the parent and saying, I want your taste class. Meaning that if I just left it the way it is, when I ran the taste method here, it would say, oh, what kind of cake is this exactly? Because in our cake class, that's what's being printed out, our parent. So super means call to my parent, cake class, and say dot taste. That's what this line is doing. Unfortunately, I don't want to do that. I want to make my own, I'm my own independent kid, so I want to say, oh, so cheesy. Or what did I say? Sweet cheesy goodness? Perfect. Take that out. All right, so we have all of that now. So let's go back, and in here, I'm gonna go ahead and create a main. Now this is something I've wanted to discuss with everyone, and some of you have probably already seen it. We are no longer putting mains directly in our classes. I don't want to put a main in my cheesecake. I don't want to put a main in my cake. I want to make a class that holds main all by itself. Typically, you'll see these called main, or you'll see them called program. Those are two very common names. I'm going to call this one main. I created a class main for my starting point. Public void, there it is. And I place main here, and that's all I'm going to place here. This is it. Only my main, the method, will go into my main class, because this is where I want my starting point to be. Why do we do this? Because as our applications get more and more complex, it's going to be harder to find where you put that one main method somewhere in a class. So why not make it something that's easily findable, searchable, which we can call main or program. That's why we place these into its own class like this. Any questions on that? Any question at all? Because into the future, this is what we're going to need to do. So your assignment 2, you should have already seen it. I think assignment 1, you might have seen it. Assignment 3 and 4 are also going to be just like this, as well as all of our exercises in studios, or at least a majority of them. All right, if no questions, we're going to make cake. I'm going to say my chocolate cake. And then in here, I have my sweetness scale. I'm going to say 7. What I just did.
This one's true.
Say it again, Matt.
Hopefully this one's true.
Like actually being the sweetness scale of 7 or something else?
No, it was a bad joke. Sorry.
No, it's okay. My mind's on cake, so I'm sorry. Sorry to get it. Okay, so as we can see, I made a more specific type, chocolate cake, and I saved it to cake. Now, can someone tell me why I just was able to make a random cake? Random cake. Why was I able to do this? What are we missing on cake if I was able to do this?
Yeah, sure.
Very good. Abstract. If I came over to here and I put abstract, then we would get that error. As you can see, one related problem. Now it's going to yell at me. So that's what we did here. We had to make it abstract. So perfect. And now the next one I'm going to do. Cake, my cheesecake. Let's say sweetness scale of 8. Because cheesecake's always better. Personal preference. All right, so now we're gonna do taste tests on both of them. Taste. Perfect. All right, what will our output be, everybody? What's gonna be the first line? What's gonna be the second line? Anybody got an idea?
7 and 8.
So remember, we're running taste. What would taste be?
It's going to be
Chocolate goodness.
chocolate goodness and what did you say for cheesecake?
Cheesy.
Sweet,
Something
cheesy
about
goodness.
cheesy goodness. Yeah.
Half I wanted to make sure everyone knew what we were doing, and half I just wanted to hear the entire class say those lines because I think it's hilarious.
Well, now that
All
I've said
right.
it out loud, I want these things, so thanks.
Right? You're welcome. All right, let's run and make sure that we're not crazy. Oh, and what happened there is I pressed start, but I did not press it from here, so my last configuration was not what I wanted. So we're gonna start it up from her. There we go. So the first line is so chocolatey, and the second line is sweet cheesy goodness. Exactly what we want to see. Any questions on this?
So I do not get the whole abstract thing. Maybe I just haven't gotten far enough into the reading, but I literally don't know why we're doing that.
That is an amazing question. Why do we do this? It's like you're reading my mind in it. It's like you got cake, you got this one. This is great. So what a great transition. Hey, Sandy, I'm happy I pay you to do this for me, to make me have these good transitions. All right.
Worth every dime.
So why do we make these, why do we extend classes? Why do we make abstract classes? What's going on? What are we doing? Let's take what we kind of just did there. We have our chocolate cake, the choco goodness, and then we create a new chocolate cake that has sweetness scale of 8. Then we create a cheesecake, happiness on a plate, with a sweetness scale of 7. That's where it gets fun. We're gonna create an array list of cakes, my cakes, because I'm opening up a cake shop. What we can do now is that we have the cake, the general type, the abstract class type here, cake, but we have chocolate cake up here, the more specific type. So what we can do is add choco goodness to my cakes. Because we have an abstract, more general cake type, we can add all of its children types, the more specific types, into data structures like the array list with it. Let's go one step further. We also have cheesecake here, which is also a child. So does that mean we can add it to the array list too? It absolutely does. Because cheesecake and chocolate cake are both children of cake, they can be added to the same array list that's set to the general cake type. I'm being a little dramatic today. This is why we want to do abstract classes, and this is why it truly helps us. Let's take it one more step further to see actually the uses of this. What if I wanted to taste all of my cakes in one sitting? Well, if I didn't have abstract classes, I would have to go to each cake and test it individually, which is line by line by line. If I had 100 cakes to test, I would have to go line by line and say cheesecake.test, chocolate cake.test, carrot taste.test. I would have to do it line by line if I didn't have an abstract class or a general class to go by. But when we bring in abstract classes, general classes, parent classes to work with, we can start creating a loop. I can create a for each loop here to help me taste 100 cakes in only 3 lines of code. What I do is I say for, I want to loop through my cakes, which again is that array list of general cakes, and I take each cake. And what I do with this general cake type is I taste it. If I had 100 cakes to taste, I can now taste them in 3 lines of code instead of 100 lines of code.
All right. Forgive me, but that second cake inside the for loop, the lowercase cake, what is that?
Are we talking about this guy?
No. Next to one line up.
This guy.
That one.
Yeah,
What
I
is
was
that?
gonna ask the same.
So in for each loops, what this does is deconstruct an array list. It opens up the array list and looks at each compartment. Are you with me so far?
Yes.
In each of the, think of if you open up a dozen of eggs. Pretend a dozen of eggs is an array list. You open it up, and now you want to go through each egg and look at it for any shattering or any breaking. What this for each loop does is it takes that individual egg out of the carton, looks at it, and then you can do whatever you want with that egg. That individual egg you took out of the carton is that cake. It's looking at each individual item of the array one at a time. If you were this for loop, going through the dozen of eggs, you have to take each one out of it one by one and look at it. That is what we're doing here. We're taking each cake out of its carton, out of its array list, and doing something with it. That's what cake is here. It's saying, hey, I just want to create a data type for my general egg, my cake. That, in essence, is what cake here is.
Okay. And again, essentially, we could name that whatever we'd like, whatever we need it to be. It's just for the sake of, keeping everything together and similar. You've named it the same thing as the array list because that's
Very
what's in
good.
the array list is cakes.
Absolutely right. I could name this bird if I wanted to.
That's
it doesn't
very
have to be
strange
cake.
Yeah, that'd be
It's very strange cake.
Yes.
Exactly. You can name whatever you want.
All right. Thank you much.
Yep. Dylan, yes. The question was, is there a way to add all the child classes to the array list with a single command, or do they have to be added individually? We actually have seen that in previous exercises. So let's go over real quick and do this taste command that we just talked about. I'm going to create that array list of cakes. I'm going to call it my cakes. Array list. There we go. Oh, come on. I got to remember that shortcut. I used to do it on PCs, but I can't remember on Macs. Okay, so the question is that, well, first, how we did it right there was my cakes.add my chocolate cake, and then my cakes.add my cheesecake. The question was asked, can we just do this in one line? You absolutely can. If I had this more, say, down here, and already had my cakes made, and say arrays.asList, and then I can place my chocolate cake in here directly, and then my cheesecake. This is a way you could do it right in line without having to do this. So if you want to save yourself a few lines of code, that's one way to do it. Dylan, does this answer your question?
Yeah, it does. I guess I was just thinking more if that array list of child classes was big, like if we had like 10 or 15 of them, if we could just add like cake and it would select all of them.
Say that one more time.
So if we have several child classes, if there's a way just to put the parent class in there instead of listing all of the child classes, is what I was hoping for.
Okay. I guess I would have to see. I'm trying to follow. Would you be creating variables like this, or are you trying to kind of not create variables like this?
No, I am. I was just thinking like where we did the arrays.addList, just where each cake was listed in the parameters there. If there is a way just to do like the parent instead of all of the children classes.
Oh, well, no, we had to, okay, I might be following you, but we do have to use the child classes because we have to define what kind of general cake it is. We can't just use the general type because in some way we have to specify what kind of cake it is. Remember, cake is just general. We always have to build the more specific type. So we can talk offline more about it.
Yeah, I think that answers the question.
Okay.
Thank you.
Yeah, absolutely. All right, so one last thing we need to do is that we said we were going to try this for loop out. So who can help me out with this? We're going to make that for each loop. What do I put in here first to loop through all of our cakes?
Cake of cakes.
Cakes.
I'm going to call this one bird just to prove my point that you can name whatever you want.
Hey, now.
All right. I'm just saying, I want to make sure that you believe me because I could be lying to you. I just like have a confident face with just a bold face lie or something. So we have a colon. What do we put in next?
My cakes.
Fantastic. And then we're gonna taste this bird. Hence why we like to keep the names consistent, so it doesn't sound as weird. But I will taste a bird. Why not? Oh yeah, we eat turkey, right? That's a bird.
I'm just gonna believe that it's the birds tasting cakes, so it's not weird.
There you go. Yeah, perfect. All right, let's go ahead and taste this cake. Bird cake. And we still get so chocolatey and sweet cheesy goodness back. And now we are tasting all of our cakes in 3 lines. Thumbs up.
I have a quick question.
Yeah.
I don't know if you said this or I missed it or something, but is this only possible through making cake an abstract class, or was that not part of this?
So abstract class just means it can't have an instance created of it. It's kind of like that's its characteristic. But to answer your question, no, it does not have to be an abstract class. We just took out abstract there. We go back to main. Everything's still happy with us. Abstract, remember, the property of abstract and why we make abstract is so we don't make those general classes that don't mean anything. Remember, if you go into Dear Birds or Schnooks and you ask for a cake, they're going to be like, what the heck are you talking about? Do you want a vanilla cake, confetti cake? What do you want? When that kind of question is proposed, it's typically an indicator we need to make something abstract.
Okay.
All right. So let's hop back here and talk about one more thing. Why would we actually do this in real life? So what if you're out there, you're a big developer now, and you have multiple clients, but you need to charge them their monthly fee for you being an awesome developer. Well, you have client 1 that pays with Visa, and you have client 2 that pays with MasterCard. Both of these are credit cards. They hold numbers, but they must be treated differently. You have to call to different charge systems to charge a MasterCard or charge a Visa. But you still don't want to have to write gigantic programs for 2 individual credit cards. You want to utilize shared information or shared methods between the 2 when necessary. So you create a credit card class. That credit card class we create an array for. And we can add our clients, client 1 and client 2. And all we have to do then is call to its specific charge class and do this all within one swoop by doing card.charge. This is how we can now use what we just learned in the real world to save us time and effort instead of having to duplicate a bunch of code and, well, just having to work weekends. This is how we can get around that. This is how you make a less of a bad Monday. Using abstraction, using inheritance, using polymorphism, and using something that's, well, we're about to learn. So any questions about this? All right, so let's move on to that new thing I just talked about, that very elusive, like, oh, Kyle, what did you mean? Like, what are you talking about? Foreshadowing too much. Well, let's talk about cake. Again, crazy, right? We have that chocolate cake, we have that cheesecake. Nothing new there. But we are on the greatest British baking show. So when you're on this beautiful baking show that is absolutely just a beautiful, amazing show to save you on a boring, rainy Saturday, they don't just do cakes, they also do other desserts. So if we needed a way for our judges to react to all of our tasty treats, we don't have just a cake class there, we could also have pie. If we have pie, that means somehow pie and cake definitely have things in common. Maybe they're both desserts. On the greatest British baking show, our judges can react to both cakes and pies. They can react to all desserts. So we can create a method called the judge's reaction on desserts. This is just a typical hierarchy. We haven't said anything new. I'm just kind of lining up a nice little storyline about delicious cakes and pies and desserts. Any questions about this before we start diving a little bit deeper? Because typically, the question we would be asking ourselves now is that, do we want to make dessert an abstract class, or do we just want to leave it generic? Well, from our conversations, we already know that cake is an abstract class, so dessert's looking pretty good to be an abstract class. But don't forget, we have one more thing in our toolbox that we all enjoy from our reading, which is the interface. We have to now decide if we want to create an abstract class or an interface. Now, if you read anything about interfaces, you know that they're quite similar to abstract classes, and you might be asking yourself, when the heck do I use when I do something? Wow, it is Monday. When do I use an interface, and when do I use an abstract class? Well, that's a fantastic question to ask, and we're gonna dive a little bit deeper into that. We're gonna look at that dessert and that judge's reaction, but we need to decide, is dessert going to be an abstract class, because that's completely fine, or is it going to be an interface? So let's go ahead and divide these two up. Abstract classes, we've seen these before. It's if we want to provide some serious structure to our children classes. Essentially, we want to define functionality for our children to have. As you saw in this cake abstract class, we defined these methods here. We said, oh, you taste like this. We defined class variables, things like that. We defined serious structure for that abstract class. Essentially, what it's saying is that you must have these methods, and at the bare minimum, it must do this. It's providing that functionality. That's what abstract classes are all around. Let's turn our focus now to interfaces. This one is a little bit more laid back. If you have a list of or you want to use interfaces, if you have a list of methods with no real set functionality that you want to have as a default. Now, what do I mean by that exactly? We are going to be establishing a general contract with our children classes. That's what interfaces are for. Abstract classes are to make more heavy demands on the children, like not only do you have to have these methods, but it must do this. Interfaces are a little bit more laid back to where we're doing more general, like, okay, you need to have these methods, but essentially you decide exactly what they're gonna do. I might give you some bumpers here and there. I might give you a small default or something like that, some small functionality, but in the end, it's all up to you. This provides a general contract. That's what interfaces are for. Now, I know we're probably not sold on this. This is still a little, let's say, nebulous or ambiguous, so both big words. Let's dive a little bit deeper into it. If we want an abstract class, choose an abstract class if your parent requires class variables. You cannot create class variables in an interface. So if your class needs those, most likely it's going to be an abstract class. Private methods. Interfaces cannot have private methods, nor can they have private variables, hence no class variables. Nothing can be private in interfaces. So if anything needs to be private, it's a pretty big calling sign that it's an abstract class. Complex functionality. If you have very big complex functions you want your children to have, another thing that's a very big call out that is probably going to be an abstract class. Again, turning our focus now to interfaces. Interfaces are good if we only have public methods. Again, just providing that general contract. I want my children to have this. Only having public static final variables inside of it. These were, again, remember, static and final variables are something that will never change and are directly, are directly accessible from the class. So these are going to be like very big constant variables, like the speed of light or the taxonomy of a dog or something like that. Things that will never change that you can access. It doesn't matter how you access them. That's a typical indicator you're going to want an interface. And then finally, simple functionality. We can provide some default functionality to our methods and interfaces, but we don't want it to be too complex. We want to keep them fairly simple. Right here is how we decide if we want an abstract class or an interface. The only method I have right now is judge's reaction. And every class is going to have, or every type of cake and every type of dessert is going to have its own reaction. So I have no real set functionality I want to do it with. And it's probably going to be public. So between those characteristics, do you think we should choose abstract class or interface for our dessert?
Interface.
Very good. And it's also the name of the section. So very good choice. We're going to do interface. So let's go ahead and hop over, knowing that we're going to do an interface on dessert and talk about interfaces. How am I doing on time? I don't even know where my phone's at. Okay. So, interfaces. Oh, geez. Just mess up everything. There we go. We have our interface. So how we start that is we say public, because we always want our interfaces to be public. The keyword interface, and then dessert. That's it. One more thing is that we want to define judge's reaction. Remember, public is the only thing that can exist inside of an interface. So if public's the only thing that's ever going to exist in here, we don't actually have to define public. That's why we can just put void judge's reaction. We don't have to put public here because we already know it's going to be public. It's basically a moot point at that instance. You don't have to say that. So you just say void judge's reaction. Now I did hint that we can create functionality or we can create a method with some functionality already assumed in the interface. That's completely true. If I wanted to say I wanted these judges to have a score, what we do is we use that default keyword there to define a method that has some default functionality to it. The difference between these two things now is that default means it's optional to define this one. You don't actually have to redefine default when you implement an interface. The one up here does not have a default action or default functionality, so it must be defined in the children's classes. You will get yelled at. Excuse me. One more thing. I said a word about interfaces. When the class implements dessert, we have to use that keyword implements. So this is how we have to implement our interfaces. We don't use the word extends. Extends are for classes and abstract classes. Implements is for interfaces. Think I goes with I. Implements, interface. Good way to connect them. So I'm assuming no questions at all, right? Just kidding. Any questions on this?
Kai, one quick question. So is only a parent class implements an interface?
Technically, anybody can implement an interface. An interface is just, like I said, a general contract, a blueprint to how you should make your class. So a child class can implement an interface as well.
In
What do I mean by that?
Sorry, go ahead.
Go ahead, John.
In Java, are we able to implement more than one interface on something?
What a great question, because I didn't put that in my slides. In matter of fact, you are. You cannot extend more than one class, but you can implement as many interfaces as you want. So if we have multiple interfaces, say we have dessert and also food, the interface, you can implement both of those on chocolate cake. Or cake. Or cheesecake. Great question, Sean.
I have a question.
Yes, what's up?
Can an interface be instantiated?
No, just like abstract classes, they can't be instantiated. No instances can be created from interfaces. Let's go ahead and take a look at, oh, go ahead, sorry. Oh, was that good?
Yeah, I'm good. Thank you.
Okay. Let's go ahead and see it in practice. So we come back here. I'm going to create an interface. Now watch this very closely in IntelliJ. You click Java class, you type in dessert, and then you click interface. This is a very important thing. So it sets up an interface for you. So dessert, yeah. When you click that, it will put interface here, not class. So if you do want that help from IntelliJ, definitely do that for interfaces. Like we said, we need to create judge's reaction. How do I create judge's reaction in this interface? What word do I start with if it doesn't return anything?
Void.
Very good. And then at the very end, I put semicolon because I'm not going to give it any definition. Then I created a default, I forgot my return time. Then I said I was going to create a score. I use that keyword default first, and then I say int score. I'm providing default functionality for my score method, as well as a return type. Do default methods always have to have return types? Absolutely not. This is just an example. Same with judge's reactions. Does it always have to be void? Absolutely not. This is just an example. We could definitely put int there if we wanted to, or string or whatever. So let's go ahead and implement. We have our abstract class here. Abstract classes can also implement interfaces. When I do this, what happens, I'll go there. There we go. What happens is that all of those properties, or sorry, all of those methods that we created inside the interface get passed down to our child immediately. So in here, it's saying you need to implement the methods. You need to implement judge's score or judge's reaction at the bare minimum. So this judge's reaction now can be implemented on my chocolate cake. So I can say is system.println awesome goodness. So there we go. That's our judge's reaction on that one. But we're also going to get an error on cheesecake because it also extends cake, which implements dessert. So down here, how are we going to fix this one? What do we start with? What do we start with? We need to implement judge's reaction at override. Very good. And then we say public void judge's reaction. System this line. And this one's a make clear winner because cheesecake always wins. And there we go. We have our judge's reaction for our cheesecake. So if we go back to main now, we're tasting our birds down here. But what if we wanted to get that score out there instead? We can say bird.judge's reaction. Remember, judge's reaction comes from dessert, but cake implements dessert. So therefore, cake has judge's reaction in it, so we can call to it from the general cake class. So real quick, let's run this. We have awesome choco goodness, and we have a clear winner. All said and done, we are good on the judge's reaction. Another question you might be asking yourself is, okay, we have cake up here, but can we put dessert? And the answer is yes. We can put dessert in here. Interfaces are technically a data type. They just can't be instantiated. So we can use those general data types in our array lists, in our hash maps, in any data structure that we see fit, just like this. And everything should still run. Oh, no, it won't, because I don't have that up there. There we go. So here's our sort. There we go. There we go. We had to rename dessert down there, but we can still use dessert as that generic or general data type like we were doing with cake. So this is the first introduction into interfaces. They're a lot like abstract classes, just like the properties that we were dealing with abstract classes, except that interfaces are defined a little bit differently, and they're more general and much more laid back than abstract classes can be. Definitely less in complexity as well.
I have a quick question.
Yeah.
So if cake, the class cake implements dessert, why is it that we need to replace, so on line 22, why does it have to be dessert then bird in order to get judge's reaction? Why couldn't you still just put cake, considering it implements dessert anyway?
Let's switch this back to cake.
Okay.
Why can't I put chocolate cake in here? Because chocolate cake is more specific. Remember our hierarchy. Remember our hierarchy. Chocolate cake is below cake. Cake is below dessert. We can't use a more specific type there. So we have to use the generic type or something even higher up. So let's switch that back to dessert. So we have to, if we wanted to put something here that's even more general, we could put object. Something up the hierarchy. That's what we have to do.
Could you
So that's why we
switch the Arraylist parameter to cake and keep it dessert for the for loop? So reversed?
Absolutely. The only thing this will cut out, though, is that we can no longer call to taste. Taste doesn't exist because it's dessert. We can only call what's at that level of the hierarchy. But if we switch this to cake, now we get the access to taste. The biggest thing to do is, if you really do get confused of what's accessible, draw out your hierarchy. At dessert level, we have judge's reaction. At the cake level, we have taste. So if we're at the dessert level here, we don't have access to taste because we're up here. We're not down here. Anybody thoroughly confused yet?
I thought I followed. So so cake does not have access to judge's score?
Other way around. Dessert does not have access to taste. Remember, everything is passed down. A dessert does not have access to taste.
Okay, so then my follow-up question would be, if you could go back to the coding that you were doing. Thank you. If you were to pass cake through on line 14, okay, but then you can't pass. Wait, no. So if you pass cake through on line 14, can you replace dessert with cake, and then can you call judge's reaction?
Yes.
Okay, cool. If you can do that, then it makes sense to me. Thank you.
Okay. Perfect. Music to my ears. So question from Lisa. So do you want to declare the lowest child level possible to use the most elements of the tree? Yes. The answer is yes. You want to stick to the most specific types you possibly can. So what that means is that if you have a thing of desserts, but you know that they're all cakes, don't use dessert, use cake. Use the more specific type, because in that way you can get access to more methods. Be greedy. Go towards the classes, the more specific classes that have more methods to help you. Lisa, does that answer your question?
Thank you.
Okay. This is a lot. We are building on inheritance fairly quickly. So if you need to take a breath and go back and review it and everything, definitely do that. Don't feel bad. This takes a second sometimes to just wrap your mind around and build what makes sense in your own head. It took me quite some time. So feel free to ask more questions though too, because at this point we are done.
Can you show us how to implement multiple interfaces?
Yeah, absolutely. Let's go ahead and create a food class or a food interface. Can someone tell me a property of food?
Cook time.
Cook time, I like it. Let's call it cook. All right, so we created a method in here called cook, and this is an interface for food. Can interfaces implement interfaces? Let's check it out. What did I say? Dessert. The answer is no, but I just always want to see it. Yeah. You cannot implement, interfaces cannot implement other interfaces. So let's go ahead and hop into cake. I always forget the notation for this one. Okay, food. Yeah, there we go. So if you want to implement two interfaces on a single class, this is how you can do it. You say dessert, comma, food. We're getting two related problems again. So let's go ahead and take a look at those. You go into chocolate cake, it says we need to most likely implement that method, cook. So we implement that. We implemented cook here. And now we go over to cheesecake and we do the exact same thing. At override, public void cook. ln. Like that. This is a way we can implement two different interfaces all on cake. It is a dessert and a food now. So it has to have the structure or that contract of dessert and of food. So what does that mean for our data types now? Well, now we can put food in here as well. It can be now a food and it can be a dessert. Boom. But again, we don't typically want to do this. I'm just showing you just for an example. We always want to stick with those specific types, which in this case will be cake. So always make sure that you stick with those specific types. More specific types. And let's run cook. Smells great, delicious, awesome. What if we took out abstract here? Well, then we're gonna get a ton of errors because why we didn't have to implement cook and what was the other one? Judge's reaction in cake is because it was abstract. Java knows you're never gonna create an instance of this. So it just passes all those responsibilities to the next standard class child. The next class that isn't abstract, that's a child, which was cheesecake and was chocolate cake. So if you take out abstract here, we're gonna have to define all those methods. So I'll have to implement judge's score or judge's reaction and cook here if we did that. Hence another benefit for saying abstract. Can we take food and just implement it directly onto the chocolate cake class? Well, that's a great question. You absolutely can. I know, I'm going. So you can say extends cake and then implements food. Oh, because it's not a cake. So we're getting a problem here because cake no longer implements food. So cook is no longer there on cake. So we actually could not run cook. We'd have to do this individually on the instances. So we'd have to say my chocolate cake.cook. Oh, because I ran cake. I was like, what's going on? So I'd have to actually make the more specific type there. So my chocolate cake dot cook. And down here, we'll have to go back to taste. Something that cake shares with both chocolate cake and cheesecake. Is this shuffling act confusing everybody now? I just want to make sure everyone leaves with just the biggest amount of confusion as possible in their heads. And I feel like I'm achieving it tonight. Daniel, you don't look convinced.
Sorry, I was just trying to think through. You had mentioned or reiterated that you can't, or we're not creating an instance of the cake class, and that's apparent with the abstract thing. But I guess we're creating an instance of the chocolate cake here, aren't we?
Right here?
Yeah.
Absolutely. Remember, creating an instance does not happen on this side of the equal sign. This has nothing to do with the instance. It just stores it. This is creating the instance.
Right.
That is creating the instance. We don't have new cake here at all. But we can store our instances in the more generic types, like cake, food, dessert.
Okay.
Look a little bit more sold, but I'll take it.
How about this? I'll jump in with another question. So when's the last
Go
time
for
you
it.
actually used interfaces in the real world? Like, can you give us like a real world, this is when we did it kind of thing to kind of give them an idea of what was used?
My domain's so boring though. Okay. Well, in my job, I have, oh gosh, no, I like more lively updates because my job's so boring. I work with Bayer, so I work with corn. And out in the field, corns have questions. How tall is the corn? What color is the corn? But questions, kind of like what you all did with your quizzes, questions have certain characteristics to them. The question to ask. So an interface, what I would do is I would create standards when we want to ask questions to implement it. So I feel like I'm going to lose everybody with corn. But essentially, I do use this in my job a lot. And what I do is I use it to tell all my other classes, all my future children's classes, how to act and behave.
Okay, yeah, that's going to get way off track. I'll try to keep it from crashing.
No. It's okay.
What about implementing iterable so you can iterate over something? I mean, can we use that as an example here to kind of bring it back home?
Maybe.
So a class needs to have a method for how to iterate, how to get the next thing to be able. So you have to, for a structure to be iterable over, you could iterate over something as long as it implements that iterable.
Oh, dude, Sean.
As I said, that might be a little too deep down into things as well.
You're
Sorry.
shoving me under the bus tonight. No, me and
No.
iterable.
I was gonna say something along those lines is just where I was trying to come with. Just trying to come up with more examples of when it actually gets used instead of just the academic showing it to them. Sorry.
Right. No, for sure.
I find the real world application super helpful, by the way.
Good. So hopefully the credit card thing. Yeah, I didn't know how much time I was going to have tonight, to be quite honest. So that's why we have some extra time tonight. Yeah, me and intervals don't really get along too well. I was telling, I think Kim earlier, I was helping her out that, they picked on me in high school. So I don't really like them. They pushed me into lockers. So I don't really use intervals too much. Not nice people. So I'm looking at the interval right now. But intervals are a common interview question. So definitely look up intervals. So I'm trying to think. Well, while I'm thinking of an example, does anyone else have, Sean, any other questions or anything that you think I missed there? I am really trying to think of a real world application.
No. It's a difficult concept. I was just trying to come at it a different way. I heard a lot of silence, and I figured I would just make you spout out more information instead of letting the silence just sit there. So it's a complex topic. It's the kind of thing where it takes using it to do it, and then you don't know where to use it because you don't know when you're going to need it. So it's.
And another example I can think of is like closable, like how you have to close the scanner. But
that would be definitely one. Close. So anything that stems off a scanner would also have to close for safety reasons like that. Yeah, that's a really good one too. I'll challenge the TAs then tonight. If you all can think of any good
John
examples.
and I just came up with two, man.
Wait, what was the second one?
The closable interface
Oh, no, what's the first one?
is the iterable.
Oh, the iterable. Okay. The iterable one is hard. Well, I'm thinking real world application. Sorry, when I'm thinking real world, I'm like the credit card example. So I'm trying to really think of just something in just plain context here.
Okay, when I worked
Those are
for
also really good.
When I worked for a television studio and we were writing different apps that would come up and pop up on the screen, so different pop-ups and this, that, and the other, we had to have them so they would implement a couple different interfaces to be able to be recognized. The same thing here is we were creating so everything would fall into cakes because we're doing something with each one of those cakes in a more general thing. So when interacting back with the framework that we were working with, we had to implement certain things, which meant we had to put certain things because the framework forced us to implement certain interfaces for it to do what we wanted it to do.
What about like an airport? Wouldn't you have to use that in an airport in some way? Iterating over like flight times or something?
That could definitely be one. Flight times, airplane types, like, airplanes all share different qualities, but we have dozens of different types of airplanes. You could definitely implement that. Flight times, you're going to have a pilot, you're going to have a takeoff time, a landing time. So those are shared properties. And then you're always looking for shared behaviors too to throw. That's what you typically throw into interfaces, is that you look for behaviors, not necessarily properties. So tonight's example, we'll kind of get a little bit more into depth about that. But for interfaces, we look for behaviors. So for the cooking example, the behavior is that you cook a cake or you bake a cake. But how long you bake the cake for, say 20 minutes, is a property. But the behavior is that you cook a cake. That cooking of the cake is that behavior which you can implement into an interface. So it's really just knowing those differences between behaviors and between properties is really will help you out in building interfaces and abstract classes as well. So I guess that would be one point I did kind of, I didn't really elaborate on tonight, is that interfaces typically implement or have behaviors, methods only inside of them, not class variables. But because I am just lacking on the real world examples, thank you very much for Alexandria and Sean for telling some better real world examples than I can about interfaces. Hopefully they'll come next week with a couple of them. But in this case, I
like the one you did with the airport. I was going to say, because you'd want to make sure that before you send a plane in the air, you'd want to make sure that that class you're sending up as a plane, you could bring any crazy thing to the runway. But unless you have a method land, I'm not going to let you take off because it would be unsafe if we didn't know how we were going to get you back onto the ground. You would need to have a method take off. You would need to have a method land. You'd have to have a method communicate with tower. So those would be things you'd throw into an interface before you let that plane take off.
Definitely.
That's good.
Cool. All right. Well, in that case, I'm going to just let everyone, no one has any more questions. I'm just going to turn it over then to the breakout rooms. Tonight, we're going to be messing with some CDs and DVDs, so that's going to be fun. But I'm going to leave it there. Discard, there we go. So thank you very much, everybody, for joining in tonight. I hope everyone enjoyed it and got a little bit more out of it for interfaces and for abstract classes. But have a great week. We do not have class or lecture, so we don't have any lecture next week or this Thursday. But I will see everybody back here on Monday. So everyone have a great weekend. Have a great rest of your week. Thanks again for coming, and I'll talk to you Monday.
You too. Thank
All
you.
right. Thanks a lot, Kyle.
Thanks, Kyle.
You have a good one.
Bye, everybody.
Thank you.
Thank you. Thanks, Kyle.
Absolutely.